Welcome everyone to Harnessing the Power of Distributed Processing, Managing Data Across Clouds and On-Premise. I'm joined today by our two lovely presenters. I'll hand things over to Richard first, if you'd like to introduce yourself.
I'm Richard. I've been at SAFE for about 9 years now, and I work in the support department here. And we support people's infrastructure and architecture. So that's why I'm so excited about the remote engines, because it opens up a whole bunch of possibilities for us. And I'll pass off to Don.
Yeah, my name's Don Murray, and I have a new joke. I've been here since the dawn of SAFE software. So there you go. So I love it here. I love to get to work with amazing people like Richard, Steve, and Elizabeth, and the team at SAFE, and spend a lot of time on the driving product. But of course, we now have 270 pairs of eyes that help us all collectively build the vision based on what we hear from partners and customers like yourself. So yeah, and I too am very excited about this whole topic. I did a master's degree actually a few years ago, we'll say, on distributed and parallel processing. So it took me all this time in order to do a webinar on it. So I'm pretty excited. So yeah.
Awesome. All right, and also note we have Steve, if you're just joining us and didn't hear, on the back end this morning. He will be helping us answer any questions that you might have during the webinar. So speaking of which, feel free to get those into the questions tab throughout as we go through here. And then keep letting us know where you're tuning in from in the chat. We'd love to see it. We do have a poll coming up in a few moments as well, so keep an eye on that polls tab there. And you can also share your emoji reactions with us during the webinar. We love to see those. And then lastly, I'll note the help button. So if you do have any audio issues during the webinar, you can click that button for 4 simple steps. The first of which is always just to give your browser a good old refresh. All right, and with that, we will head into our poll here. So I will go ahead and launch that in the polls tab. And we'll give everyone a moment there to cast your vote. But we'd like to know what best describes your data landscape. A handful of different options there. Oh, it looks like a few are in the lead so far.
Nice.
All right, it looks like most votes have come in now. So if our presenters want to head over to the polls tab and take a look with me, it looks like hybrid is the largest number today. So about 43% of the audience.
Yep. And then it's surprising, how many are just on premises. Only 18%, and the rest in some fashion are distributed. So on-premise in one cloud. I don't know where my data is. That might be, those two people are probably the most honest of all of us. Sometimes I don't know where the data is, and so so that's good. So yeah, awesome. So this topic clearly resonates with this audience, and so that's great. I do want to point out one very important thing here. Elizabeth is running the slide deck, so if there's any problems, then you don't have to wonder, was it me or Richard or Steve? It was 100% Elizabeth, so I want to get that out of the way. Right, Elizabeth?
I take full ownership.
Okay, so I guess, yeah.
Great. Perfect. Yeah, so at this point, I'll get our presenters to turn off their webcams just so we can save on some bandwidth here for the rest.
Okay, perfect.
And I'll take us through our agenda here today. So first, we will get started with setting the stage. So Don and Richard are going to cover key challenges and strategies with scalability, security, and compliance in mind. And then from there, they will take us through how to leverage FME Flow and Remote Engines Service. And then they will go through the benefits and CPU time license option, as well as some impressive demos where they're going to walk through what's possible firsthand. And then to wrap us up, we'll share resources and next steps to help you get started. and host a live Q&A segment. So at that point, we'll address any questions that you might have today or elaborate on any that Steve might have gotten to already in the questions tab. Yeah.
Perfect. Yeah, so setting the stage. So organizations today, we're faced with, a very changing data landscape. There's things that are coming at us that we can control. And then there's other things that we can't control. Like when it comes to where our data is located, there's some sovereignty issues that dictate where data cannot be and where it must be. Of course, security is driving a lot of things. Compliance, digital sovereignty. More and more organizations, as we saw in that poll, the data is distributed. That is just the reality that is in front of us all. You're going to see in a few slides how data is not just moving to the cloud. Some data is actually moving back to on-premises. As organizations, we start to understand where it's best to do data. Obviously, egress charges, moving data out of the cloud has some costs. And so just being able to move the data where it makes sense for your organization is what it's all about today. We want to drive home the fact that no matter where you want to put your data, that's where with the FME Remote Engine Service, you can put it. And so, because the last thing that you need is another restriction on that's going to dictate where you can put your data for the best performance and security. And so that's really, what we're talking about today. So, yes.
Yeah, scalability is key too. The volume of data is changing a lot, the variety and the velocity of the data, and of course the veracity. And FME has always been great at veracity, but we need a solution now that covers more of those ebbs and flows in the scalability. And we have to be able to scale vertically and horizontally and geographically.
Yeah.
So we've got to have a very dynamic solution here, whatever it is. And then in terms of the distribution of data, as we saw in the poll, people's data is a lot in the cloud. There's a lot of people who have on-premise, and you need a solution where you can process these things all locally rather than try to pull it across all these different environments.
And so one of the key things, of course, is flexibility and agility. Your data landscape is constantly changing, as this shows. So, and you can see that there's, there's even one of those that says moving data to, plans to migrate data, cloud to on-premise, automate, annual data transfer increase. There's just so many things going on. And for when you look at the cost, optimization, cloud to on-premise, that's kind of surprising when I started doing the research on this. 25% of organizations do have some data they want to move back to on-premise. And then you have compliance and security. A day doesn't go by where we hear about, some sort of, data breach. And of course, that also dictates, some data is moved on premises to be more secure. Other organizations are moving to the cloud. In the US government, there's a big move to have everything in the cloud. And again, it's security, digital compliance are really, really driving all of that. And so if you're when you're looking at data integration, you really need to, it has to be where your data is. Pulling data out of a cloud or on premise to some remote place for processing it's just not a good idea. It opens up the data to yet another attack surface. And whereas if you move the processing by the data, by definition, the data is moving less, it's less exposed. And so there's lots of reasons why, you need to get a data integration tool that can change as your data landscape's changing, not one where you're having to make compromises. Yeah. And so, data security, these are the number of major data breaches reported. There's a lot of, data breaches that aren't reported. There's a city in the United States, I won't mention the name, where they've actually paid ransom 6 times, right? And so, which is just a bad idea because, of course, now everybody knows they're going to pay ransom, and so they're a nice target. And so, but data security is top of mind for every organization. You meet with any IT organization, and data security is front and center. It's kind of interesting, we talk about, the value of things. And when organizations look at their assets on their balance sheet, they'll have, the assets of all the equipment, the buildings, all the physical infrastructure. What's the value of the data? It's actually probably more than all that put together. And I think, we're really starting to understand that. So you can just see some of the things you don't want to do. You don't want to move your data more than necessary, and you really want to restrict the data access, as much as possible. Yeah.
Yeah, and beyond that, often there's digital sovereignty, so you can't even move the data out of wherever it resides. So we have to deal with that now too. And you can see that it's increasing. All these regulatory requirements have been increasing a lot over time, and we're only going to get more. So these restrictions are now something we have to work with. It's a real problem, and we have real solutions for it. But that being said, we should always process close to the data, and when you can, it's going to improve your performance. It's going to improve your security. It's just a good thing to do. So that's the next slide here, and then we'll then move into the solution here. So remote engines is what we're here to talk about today. So the traditional view of FME flow, we've had to install everything in one network in one location, and would have to keep everything close together. We've had a lot of parallel processing ability in the past, but we've sort of been restricted on putting it anywhere. So the engines can process in parallel, and both had to do vertical and horizontal scaling there. And
Yeah,
then,
so this is just showing the traditional FME flow. You could do distributed data processing, within one firewall setting, parallel processing, of course. Deployment. Yeah, and so FME flow traditionally has had a united control plane and processing plane. So what this means is that when you installed FME flow, you were inside one data center, inside one on-premises location, and that's really what it was really built for. So the engines are really tightly coupled to the the control plane, such that we didn't even talk about control plane and processing plane. Yes, you could have the engines, the processing in different machines, but they were in the same data center. And yes, we have had clients who have done things like punch holes through their firewall so they could have engines in remote places. But the architecture of FME flow did not really support that very well. And so now what we're doing with our own engines is we've basically separated the processing plane with FME flow. And you'll see this. We are still going to support FME flow, of course, in the traditional way, because why introduce more complexity if you don't need to, right? And all our users, I won't say all our users, but the vast majority of our users are doing that. They're happy. Some will decide just to have multiple FME flow instances, and that's fine. Whatever makes sense to our customers and our users, that's what it's all about. And so, but now what we've really added is, as you can see in the bottom part, is now you can add processing planes where you can move remote engines anywhere. So you see in the bottom one there, 3 processing planes. You have 2 engines and one is one engine. And of course, each of those processing planes, you can have as many engines as you want. It's not the FME Remote Engine Service. It's FME Remote Engines Service. So you can have them scale up, scale down, and now you can put those absolutely anywhere. So super exciting. So that's really what it's about. Passing it off to Richard here. FME remote engines, you can move the processing anywhere. And so, with that, I'll hand it off to Richard.
Yeah, you can really put it anywhere. So you can have it on premise at the same time as you're processing something in the cloud. So you can have that control plane that's controlling both those workflows at the same time. You can put it near your IoT device. It's it's pretty limitless, and the nice thing about these nodes is you can just pop them out anywhere, and use them when you need them. So what are you getting out of this? We're getting distributed data processing out of this. We're getting the parallel processing out of this. We're getting a flexible deployment, so you don't have to worry about firewalls and data centers as much anymore. You're getting the scalability of it with those engines on the nodes, and sharing the engines across all of the remote engines and the primary server there. You're getting that geographical distribution. So now you can put them wherever you want them to, and you can deal with each individual environment and the requirements for those environments, instead of having to treat it as a whole and have one unit that has to deal with everything. And then, of course, because of that, you're going to get a lot of enhanced data security out of that. So we've got one more exciting thing to talk about here. We're working on putting an FME engine inside the Snowflake environment so that your latency is like nothing and you can just process away. Yeah, it's pretty cool. But more to come on that. So the benefits of the remote engines, and we'll talk a little bit about CPU time because it's a great partner with these remote engines. So the first thing that I love about the remote engines is these replicable nodes. These nodes, you're easy to set up. You can simplify your installation with them, and you can put them anywhere. So when we're pushing jobs up, we're pushing the dependencies up. All the control is with that primary server, so you don't have to spend as much time with configuration on those nodes. And we also have the ability to do offline and online functionality. So if it's online, it's going to be processing away. If it's offline, it's going to go back into your queue, so that it gives you some guaranteed delivery. So you're going to see that this job has been submitted. And if it hasn't been submitted, again, it's in the queue. So now you've got clear stability across vast distances if you have your engines on the other side of the world.
So Richard, are you saying that if I have I have my master FME flow and I have some remote engine service, I could even send jobs to the remote engine service that is not running right now, and the jobs will queue up, and then when that remote engine service comes up, it'll then process the jobs? Is that what you're saying?
Absolutely. So you're not going to lose anything. It's just going to go into the queue there and get ready to go. And then if you wanted to do something like adjust the engines to do more engines because it was offline and process quicker, you can do that.
Yeah. I can see why CPU time is really beneficial, right? Because you could watch that queue, and when the queue gets so much work, then you could start your remote engine service through the processing, and then when it's finished, you could shut it down. Yeah, very flexible.
Absolutely.
Yeah.
And then we've talked a lot about that central control point, but we can use FME Flow or FME Flow hosted for that. So we have a PaaS service, which is FME Flow hosted. So if you don't want to host your infrastructure yourself, we'll do it for you, and it can make things a lot easier. So you can have that cloud interface online and then put your on-premise engine somewhere else, and you can have the processing work that way.
Do I have to process? Do I have to publish to each of the remote engine services, or do they just publish to the primary FME flow?
No, yeah, everything's done through the primary. So that's the nice thing. These remote engines can basically stay hidden. You never really have to go into them unless you're an admin and want to check on things. But functionally, for submitting jobs and everything else, it's through that primary flow.
So now if I have FME Flow hosted as my primary, I could have a remote engine service on premise. That's what you're saying.
Yeah, absolutely.
Nice.
Yeah, and then the other thing that I really like about these remote engines is that with all these different environments, we have different requirements. So now you can sort of silo things. If you have one department and they only want to have a certain permission to resources, that you can give that service account those permissions and no other permissions, and then use the roles in FME to be able to say, hey, this department can only process this stuff. And it's limited, it's siloed in there. So it gives us a lot more control over the environment that we're putting it in.
Yeah.
And so now we've talked about this a ton, but cutting down on the commute, install all the engines near the data. Why not when we have remote engines that are so easy to control like this? Just plop down another engine.
Yeah.
And this leads us into sort of the CPU engines. So
Yeah.
now with the CPU engine, it's not really an engine, it's multiple engines. It's a pool of resources that we're pulling from. So it's the time that we're using it. So we can have CPU engine time on all our remote servers there, remote engines, and then it just pulls from that central pool and we don't have to worry about it. So if we got a big wave of data, it just smooths out that curve and is able to handle that.
Yeah, and you're only paying for the CPU time. So if those engines are idle, you're not paying for anything. You're just so if you have 10 engines scattered and they're idle, you're not paying for anything. You're only paying for the CPU time, which is really awesome, because you do have peaky things, right? You might have a really peaky Kafka connector or something, right? That where it's a high velocity, but then at times it goes quiet, and so CPU time is great for that.
Yeah, so exactly. There's never an idle engine if you're using CPU time. So you can distribute them again. I've got a scenario here where you've got Australia and Europe. You've got maybe nightly processing. You can use that same time amongst those two machines and never have to worry about an idle engine there.
Yeah, nice.
And really the big thing is those bulk processing. So with the big waves of data, we can process it more easily, and it's a good assurance and policy in case you have those ebbs and flows that you don't think you can handle. So that's why it ties in nicely with the remote engines, where it might not be as consistent workflows.
Yeah.
So with that, we're going to jump into an intro of remote engines. So this is just a quick overview of the remote engines and how they operate. So this is the primary flow here that we have set up, and we've got it licensed. It's got some engines on it locally. But where we're going to start out is a queue. So the queuing mechanism is how we're going to send those jobs to those remote engines. And there's two remote engine queues set up here, each one to a different remote engine. They're just a simple queue. There's nothing fancy about them. And then if we go over to the remote engines, so you see I've got two services here. I've got one that's online and I've got one that's offline. And if we go into it here, I've got the URL all set up. I've got admin password, which I can change at any time from the primary flow. And then I've got the ability to select the queue. And then I've got the ability to specify the number of engines and CPU engines that are pulled from the primary licensing. And there's also the proxy if you want to be able to do that. So we're sharing those engines out between all the different remote engines here, and you don't have to license each remote engine individually. So we can remove them or we can reset the cache. That's the other thing about remote engines, how they work, is that we package everything up, we send it to the remote engine, and then it stays there. So the workspace will stay there. If we have dependencies in terms of database connections, or web connections, or packages, it's all going to stay there. So we're not moving the data back and forth all the time, but it all comes from the primary. So you don't have to set anything up on these remote engines. So we're going to run a job here. I've uploaded data from my desktop into this primary FME flow. You can see there's a database connection here. I'm going to set it up with the right queue here, so it goes to my remote engine, and I'm going to run it here. And if we view this, we're going to see that it's uploaded a few things. It's uploaded the emailer package there. It's uploaded my connection, or actually skipping this in this case because I've already uploaded it before. But you'd see that being uploaded. The file that I had, I pulled into the primary flow and then pushed it across. And we can see that it was successfully submitted. And then if we want to check out the job log, we click on the link and it takes us to the job log and all the history on that remote engine if we want to view that.
Yeah.
So what happens if we put it to the offline instance? We talked about this, but yeah, you can see it in action. It's queuing. So we don't have to worry about losing that job if it gets submitted. And I should also mention, if we submit a bunch of jobs to that remote engine, and we only have 2 licenses but 10 jobs, there's also the queuing still on the remote engine side. So it will queue up there too as well.
Yeah.
All right, so I think that takes us through the first demo.
Yeah, awesome. That's awesome. And the other thing that was exciting is, Richard quickly talked about the cache, but the thing is if the workspace and everything, as Richard said, is marshaled to the remote engines and it stays there. If you publish a new workspace to the primary, then automatically the cache is made invalid, so that the next time the workspace and everything will go over. So you don't have to worry about that. You would just author on form as you always do and publish to your primary. And if it's going to be executed on the remote engine, you don't have to worry about it. Everything will be marshaled over. If it's also run on the primary, you don't need to worry about it. And also with backing up, you only back up the primary. The remote engines are 100% disposable. You could, you could just literally have remote engine service that is part of an image on a VM machine, and when it's needed, it fires up, does its processing, and shuts down. And then every time you just start from the fresh image if you wanted. So really, really powerful. So the second demo is going to basically show how powerful remote engine service is with automation. So yeah, so this one is we're going to use automations. And the automation, this is where the control plane really comes into, shows the power. Because as many of you know, automations has this ability to launch things in parallel and then make sure things are finished before doing sequential parts. So we've just created this crazy workflow that has, some things on premise. So you have those 2 are on AWS. Two workspaces running on AWS in a queue, and then at the bottom 2 are running on Azure, and then the rest is running, on premise. So this control plane is keeping all that remote processing, all that distributed processing, all that parallel processing in sync. So you can see the top and the bottom. We're actually doing parallel processing with half the parallel processing done on Azure and half done on AWS. And then it brings it all together. So, the orchestration of this is really amazing when you start to understand, exactly what we do. And that's the power of separating the control plane from the process. I don't think anybody else does this. Definitely not in a no-code environment. So with that, we'll get Elizabeth to run the demo here. Yeah, and I'll just talk through it. Yeah, so here we go. We have 2 remote engine services. You can see very much like Richard, I have 2 standard, 2 CPU time engines on both, and they're both ready to go. And yeah, and then you can see there are ones on the AWS remote queue. I just named the queues after the names of the cloud instances. So this one's AWS, and the other one I gave the queue name. Azure remote queue. You can see the, and this one has 1 standard engine, 1 CPU, and yeah, and now there you go. We're gonna look at the queues, and you can see we have a default queue, we have an on-premise queue, and then we have our 2 remote queues that we've given names to, and then we'll look at the automation in a second here. So you can see there's distributed parallel processing, because if you're going to go big, let's go big, and this is it. And you can see all the different things. We're going to do a manual trigger so we can control when to run it, and you'll see there we go. We have our split merge. We have nested split merge blocks, so that the downstream work on the inside there will wait until the processing on AWS and Azure is finished, and then when the whole thing's finished, we will do a little bit of, other processing. So yeah. And again, this was just created to illustrate, the power of what's going on with, the remote engines. And so, yeah. So I think I'm going to click start here. Yeah, you can see the queues is where you specify under advanced. You're going to see that one's on premise queue. And literally, this is how easy it is. You simply select the queues for the different places where you want them run. This is AWS remote queue. And then on the Azure one, you're going to guess it right. Yeah, it's going to say Azure remote queue. And so now I think we're going to run it. I think I ran it. And then you'll see some counts go by. And this is where the hard part was making sure we had all the synchronization going properly. And and so lots of stuff going on here. For sure, a lot of things being marshaled and work done. And now we're going to refresh, and you'll see the event counts come up when I click on this. And you'll see that everything they're not very, very easy to see. You can see 5, 5, 25, 25, and then, 10 at the end. So 10 at the end matches the 2 5s. And then, anyway, you get the idea. Very, very powerful. And you can imagine, the AWS one's processing data on AWS, Azure one's processing data or databases on Azure. And then you can imagine with the Snowflake one, there will be a Snowflake engine for the data that's in Snowflake. And so you just start to it's just amazing what this is going to be able to do. So, and you can see why we recorded this demo. You can imagine me, I get excited and I'd be clicking all over. And that's pretty much it. We can go to the next slide, Elizabeth. It seemed like a very fast demo when I did it myself, but okay, here we go. Anyway, it would have showed you what Richard showed us, which was all the jobs working, being done. And but in the interest of time, we'll give you the deck and you can watch the whole video if you want. And the next one is I repurposed one from. We had a World Fair of data many, many years ago. I think it was during COVID, or maybe it was before COVID. Anyway, and this was one that just demonstrated the power of massive parallelism with, automations and FME engines. And now you can imagine it with remote engines. Yeah, so this one we're just going to show, how many engines can a single FME flow core handle, up to 1,000. The nice thing is remote engines, because remote engines are now scheduling all those, each remote engine, it's remote engines. There is a core in there that can also scale engines. So this also will multiply the number of engines that you can scale to as well, because the primary control plane is not going to be handling all those engines. It's going to be handling big bulks of engines. So rather than 1,000 individual engines it has to talk to, it now can be talking to 50 remote engine service, and then each of those can scale up. So it also takes the scaling to a completely different level. So and this was just showing something that for folks, what if you don't know how many jobs you're going to split into? The one that I did earlier did have the automation writer in it, and that's based on data. Sometimes you have a huge data set and you want to chunk it into pieces so you can process each piece in parallel. And so part of automations is in FME form. In Workbench, we created this thing called the automation writer, and his whole purpose in life is to be able to split data apart to drive different workspaces downstream. And so this is a splitter workspace. I'm just splitting this huge data set up into, H3 hexagons. And the worker is just going to then, basically get the H3 index that is to process and process the data within that. And so, and then the workspace center, the web socket there was just because we want to show it on a web front end. And so that was actually the bottleneck of the whole thing. It was not the FME flow processing it. It was the FME socket could not, the web socket could not handle the amount of data. So we had to monkey around there. So anyway, and here's the automation, right? Very, very simple, because the splitter workspace in this case is going to output 30,000 different H3 tiles that'll go out to 1,000 engines, and they'll process it all in parallel. And you can see how dynamic the parallelism is here. The amount of parallelism actually depends on the number of engines that are available. So if I had 10 engines, I would get 10 things going in process. In this one, I went crazy and I launched 1,000 engines. So then 1,000 engines would be running in parallel. And yeah, and the whole split merge thing in FME automations would work as well. So yeah, so next. And here it is. You can see, you know, the difference, and lo and behold, it is about 1,000 times faster. Those are minutes. Obviously, we're not going to watch for an hour while these dots go up, but you can just see, and in fact, the number of dots on the other side was about 1/1000th of all those dots specified. Each of those dots is actually an H3 index that we generated in FME flow. So this one just shows you the power of scalability. Now you combine that with FME Remote Engines Service. You combine that with CPU time that Richard talked about, and now where do you want to put the data? What do you want to do? When do you want to do it? How do you want to orchestrate it? Really, now your data landscape is really where do you want to put the data, and we will get the engines to you and process as much as you want, and that's really what it's all about. So yeah, so that's yeah. So
I love that left side. Yeah, seeing all the engines put up the data there, and the interesting thing about the CPU engines, if you want to go that approach, is that one engine and that 1,000 engines, they're going to cost you the same because it's the same CPU time.
Love it, Richard. I'm so glad you made that comment. Yes. What's the cost of the FME time? The same, because they're both doing the same amount of work. So I'm so glad you said that. Yeah, really good. Yeah. Richard and I and Steve, we love this stuff. Yeah, we really, really do. The only reason Steve's not on this webinar is he was away on vacation, and so. If Steve was paranoid, he might think, geez, maybe Dawn and Richard scheduled this webinar so that it was like the day I get back from vacation so that they could hog the stage all to themselves. Yeah, you never know. But good thing Steve's not paranoid, right, Richard?
Oh, yeah. Good thing.
Yeah, so.
All right, yeah. So we're going to wrap this up with the conclusion here. So we talked about the landscape changing a lot. We're talking about scalability needs that we're beyond what there were 10 years ago or 5 years ago. We're talking about new compliance and digital sovereignty issues, which is causing data to be distributed even more and create more security requirements for the data that's out there. So we need something that's going to be flexible, something that's going to be agile, and be able to deal with these variables out there. Yeah, so we need the ability to adapt and change to whatever was coming up. And remote engines really give you that flexibility and really simplicity of your installation. You just throw them down wherever you want, and you've got that set up to start processing right beside the data. So the main things, yeah, we're getting that difference in the control plane. Now the control plane can be somewhere else, and you can have that processing spread out to all those different nodes that are simple and replicable. And then you've got the different services where you can have it. You can host it in all different types of environments. You've got the massive parallelism, the multi-cloud environments in there. So you've got all that wonderful functionality that we've put into FME Flow over the years, and you can take advantage of that in those remote engines.
Yeah, so with that, let's just do a few wrap-up things. So yeah, so for those who don't know who we are, we've been doing this for 30 years. We have, we grew up in the whole spatial arena. Now, with the growth of spatial data being important to the entire enterprise, we tell organizations, if you're looking for an enterprise integration solution, that's a 5 to 10 year decision. And if you're ignoring spatial data, you're doing that at your own, I don't know what the word is, but you better be careful, because if your competition is, you could find yourself not able to compete. Obviously, we love what we do, and Our platform's really simple. There's two things. There's form, which is where you author the low level, build the low level piping, in Workbench. And our architecture is like a high velocity data stream internally. So whether you're reading databases or, Kafka or anything, it's high performance C++ that does the processing. So if you compare with other tools that are moving data, they just can't compete with, a high performance C++ platform that's been optimized for 30 years, with really smart people. And then you have FME Flow, of course, which brings all that power to the enterprise. And then FME Flow Hosted, which is, a cloud-based offering, which then, you can just have FME Flow workflows running in the cloud. Again, the whole thing is no code. Low code is still code. So if it's low code, you still have to hire a developer, and that's not cheap. And if you're going to do it right, you have to do code reviews, you have to manage it. There's lots of things that come along with that. So so this is what we're really proud of, the customer's choice. It's safe we talk about the restaurant model, and that is when you go to a really nice restaurant, you have to have really good food and amazing service, right? That's what you go there for. You go there for the experience. It's not just the experience of tasting good food. It's also the experience of the way you're treated. And that's, we think, again, we're the only ones in the industry that do this, and we're proud of it. And our partners embrace this. And it's a big differentiator, because when you talk to us, we view customer support as a value, not a cost. A lot of organizations, you talk to them and they're trying to figure out how to drive down the cost per customer by measuring the length of calls and all that. Nope, that's not what we do. We view you, when you reach out to us, we view you as our customer. We're running an expensive restaurant here, and we really want to give you the best service. So you see us there under customer's choice. That's alphabetical, so we're not fourth. And last year we owned that column all to ourselves, but we can't control that others are also starting to give good customer support. So anyway, but when it comes to, the customer's choice in North America, we're the customer's choice in North America. And mid-size enterprise, we are the, customer's choice in mid-size enterprise segments. So those are the ones that we own. So reach out to us. And give us a try. Yeah, you'll love it.
All right, so I'll take us through some resources to help you all get started here today. And firstly, I just want to mention some free resources that we have available. So including our ebook, Spatial Data for the Enterprise, and we have a short link to redeem that if you have yet to do so. And then as well, our FME Academy and Knowledge Base are great places to check out guided learning at your fingertips, and also how-tos and demos in the knowledge base itself. And then lastly, I'll note our webinar program. So we have lots of upcoming and on-demand webinars. So feel free to search by whatever topic you might be interested in learning more about. And check out our upcoming webinars for more to register for.
Hey, can I say something?
Yeah.
Dumb question of the week. But anyway, because Elizabeth knows I'm going to say something anyway. And one of the things that's really important about our learning is it's instructor-led and it's free. So you go to the academy, there's going to be an instructor there who's online with you. So if you have questions, you can ask them. Same thing with our online training. It's free, but it's online, led by an instructor, which means then you can ask that person question. Again, when you look at the restaurant model, that's very, very different than what other companies do. And other companies, you have free online training. You go there, it's like walking into an Amazon store where there's nobody there and you're not even too sure what you want to buy. Whereas at us, when you do our online instructor-led training by us or by some of our partners also run our accelerator online. And so that's a big difference. So thanks, Elizabeth.
Yeah, absolutely. I'll also note our podcast program. So we run that through EM360. So definitely check out our podcast. We have a couple of recent ones displayed on the screen here, some more popular ones. If you'd like to, get some more audio-based learning, maybe during your commute. In terms of next steps, contact us to chat about anything data whatsoever. Today's webinar was just the tip of the iceberg. We'd love to help you find any solutions to your challenges. I also just published a button there on the bottom left. Feel free to click that button and it'll start up an email for you to reach out to us directly. And our FME Accelerator course. If you are newer to FME, I definitely recommend checking this out. It's 90 minutes free of charge, and as Dawn mentioned, instructor-led. I personally took this course actually to learn the basics of FME and found it very valuable. All right, and claim your community badge. So if you're a member of our FME community, I will drop this in the chat now. And this is just a thank you for joining us here today, a badge code that you can redeem. If you aren't a member of our FME community, we encourage you to head on over there and give it a look. It's a great place to network with other users alike and get advice from experts. All right, and with that, I will invite our team to join the stage with me, and we can take a look over the questions that came in today. Thanks everyone for dropping those in as we went through today.
Great.
All right.
Yeah.
We got some questions coming in there. So
yeah.
Thanks everyone for engaging with the Q&A here. I think first up, Ben Allen, he's asked a great question about the amount of CPU credits that are assigned or can be used by different departments. And we showed some interesting ways of assigning remote engines to departments, but how can we differentiate who's using what in those departments? How many CPU credits? Do we have anything like that right now?
No, you can't. What you can do is you could have like a queue for each different department. So you could have like a marketing queue, and then you could have different queues, and then you could pull the jobs to see which ones, or just give different. Yeah, and then you could give just certain numbers of engines to each queue.
Right.
He asked another really good engine one as well. Is can you auto scale remote engines?
Yeah,
absolutely you can. And the nice thing about CPU credits, it's CPU time credits. We don't track the different types of CPU, which is important for people to note. So if you decide to run on a CPU that it's 1 second of that does more work than another one, then we're kind of like more power to you. So that's the other thing.
But it's just one pool of CPU credits, though, for the environment.
Right.
So if you had 10 remote engine systems and one master, that would be one pool still. So yeah. All right. And and then Lee asked, can you easily see what workspaces or apps are making the most use of CPU credits, maybe within dashboard reports? So there's a bit of analytics there at the moment, but you can see some of that, but I think there is probably a little bit of a gap there, maybe.
Yeah, you can certainly look in the CPU job logs, and then you're going to see the percentage of CPU. You can see the CPU time, and then you can also see the percentage of CPU that's used. And so that's really useful for moving jobs. If you are processing, let's say you're processing some Aurora database on AWS, and you notice that the CPU time is like 10%, then you might say, oh, I'm going to move that to the cloud with AWS Aurora. I'm going to put it in the same data center. And then when you run it, you will see that the CPU percentage time will go up, which means that the engine's spending way less time waiting. So for sure you can do that. And that's in the job history. You can see those columns for any job you'll see, or any workspace. You can see that the expected CPU time, expected elapsed time, and then the CPU percentage time and things like that. So you can do that. And that's really important when you're moving engines closer. What you think is closer to the data, you can quickly look to see if it made a difference. But, because if the CPU time is like 10%, then it doesn't matter how much you optimize that workflow. The most you're going to do is make that 10% more fast, but 90% of the time the engine's waiting for data. So if you move it and now the engine's not spending as much time waiting for data, you're going to get a big improvement. Yeah,
that's right. It's waiting or it's sending data somewhere.
Yeah, that's right.
Through network topology delays. Yeah. So as far as tracking what workspaces are using CPU credits, we're probably got a gap there, I think, right now, right? We can definitely see CPU usage, but as far as credits, so just tracking, hey, these workspaces are making use of CPU credits the most.
We should be able to see that by the engine that's running on. It'll be CPU engine time. And then we've got a robust API, so we could take that API and create a nice dashboard, and you could see exactly how much time you're using in CPU credits versus your engines. It's very flexible.
Yeah, that's right. But you develop it in the API.
Yeah, for sure. If you're using CPU time and you want to see more, let us know. That's a classic thing we ask for, because FME is never finished. FME is never perfect. We're like a restaurant. We can always add another menu item or add another sauce on your steak. Maybe we don't have peppercorn sauce on our steak, and maybe somebody likes that. So tell us the CPU time credits would be really great if you did this, right? Or say what you would like to know, and that's even better. Like, oh, I don't know this, and then that's really, really great. So, yeah. So remote engine service, how are they deployed in cloud environments? A new deployment page is coming that talks about all that. But basically, the other thing we didn't even touch on is the FME flow could be in Windows, and then the remote engines could be in Linux, or the FME flow could be on Linux, and the FME remote engine service could be on Windows, or even different CPUs, right? So there's lots of, so any way you want to install, there are Windows installers for the Windows versions. And then again, remote engine service, if reach out to us, and if you want to install and you can't find what you're looking for, let us know. Yeah.
And they're simple installers. They're really easy to go through. There's not a lot of considerations when you're installing it. It's just click and go. So you could script it out and have it on VMs to spin up a new VM with a remote engine on it when you need it. It's easy to do.
Yeah, and then good question about somebody noticed that we set up our remote engines without encryption. We use HTTP. Again, you would never do that in production. And yes, we do support HTTPS across everything, and any real organization you would do that for sure. So so good eye, I will say, good eye. Yeah.
Okay. And then I guess Lee just dropped another question in there. Have you had any tests internally? Well, let's just start live. Yeah, thanks, Elizabeth. Have you had any tests internally that have assessed the likes of processing speed improvements by moving engines close to external data? I on that point alone, I know we haven't tested it and collected that information and put it into an article or anything like that, but we certainly have experienced doing that ourselves, and there's massive differences. I've been involved in some big data movement from Snowflake and Oracle and things like that, and when I get my engines even 40 miles away versus 500 miles away, massive difference in performance. So for sure, definitely well aware of that.
Yeah,
and then
go
ahead.
And it's kind of fun actually to if you have free time and you just want to see the difference, like use an Aurora database and then run an engine in even a different AWS data center.
Exactly. Yep.
And then you run the same workspace in the same data center. It is, huge difference. And the speed of light is the speed of light, and there's nothing we can do about that. And, latency and all that stuff. So and that'll really drive home why we built it for you too. So
That's right. And then the second point of this question here too is really like, we know it's going to cost you money getting data off your cloud or into your cloud. Once you're on the cloud, moving data between all those environments, it's a lower cost point. So that's another part of this is why we want to get those engines close to the data, into the data center.
Yeah.
All right.
Great. So.
All right.
Looks like we've gotten to them all.
Yeah. So I really like the questions about analytics, and so ask us what you would like to see. Like send an click that button, or go to the community and put an idea. Like Ben's question, I'd really like to be able to see the different credits burned by different departments, and so we can we can look at how to do that, but based on queue name, and then you could figure it out, or, let us know what you would like to see. This is new, obviously, and on Flow, you can see how many credits you have left, so you can see them burn down, and things like that, but on the master flow. But beyond that, there's lots we can do. So
yeah. I think to Lee's point in the chat, he dropped in another part of that question there about CPU hours, and he really just if he sees a heavy CPU hitter workspace and he has a standard engine, maybe he moves it over to just run on the standard engine. So it's definitely something you want to be able to track. So good stuff.
Really, really great.
All right.
Excellent.
That's it for me. I'll mute.
Yeah, perfect. Thanks, everybody. We really want to thank you. We know you're all busy, and so really want to thank you for tuning in today. And we view this as the beginning of the discussion, so please do reach out to us. And we're excited about this. We see huge potential for this, but this is not done. And Elizabeth, was one thing we should really make sure everybody's aware of, and that's the Pika data integration in Seattle next year.
Yeah.
Absolutely. So that's in May. So we're doing it in Seattle next year, not Vancouver. So please, we look forward to to seeing all of you there. So
Yeah, and I believe the call for presentations is open at the moment. So I actually just dropped the link in the chat there if anyone has yet to submit.
Yeah, perfect. And registration opens in September, I think.
Awesome. Coming up quick.
Yeah, it is. So awesome.
Great. And thanks to all our presenters as well, and Steve for all your support with Q&A. Really appreciate your time.
Really great. Yeah. And
yes, and I'll just chime in and say great job, Don and Richard, with sharing this content. I'm really excited to see how our customers move in this direction with this. So great job introducing it.
Awesome.
Thank you. Thanks, everybody.
All right. Thanks, everyone. Bye for now.
Bye-bye.
Bye, guys.
Bye.